G'day and welcome to the first video in the series on discrete random variables. So this is chapter 8 in your textbook, and I guess we're going to deal with discrete random variables as opposed to continuous random variables. I'll get into I guess a definition of each of them a little bit later, although you may have some idea of them already. But there's a couple of things that I need to do before I get into the Year 12 content. I kind of need to just remind you of a few, I guess, notation type things so that you're aware of some of the things that happened in previous years. So let me just go through. This will kind of be a little bit random. It'll just sort of be a bunch of different things, but you just need to be aware of the notation of some of these things. So if we've got this E looking thing here, that's the universal set, so that's all of the numbers that are exist, and for example I'm saying that all the numbers that exist are all the numbers between 1 and 10. I'm just sort of showing you Venn diagrams and some of these sorts of things. Now if I've got A, and A is the set of 1, 2, 3, 4, 5, 6, 7, and B is the set 2, 5, 6, 7, 8, 9, I'm going to draw both of those on a Venn diagram. And it looks something a little bit like this. As you can see, that 10 is the only number that doesn't exist in either one of them. There's a bunch of numbers that exist in A and a bunch of numbers that exist in A, and some of them exist in both of them, so they go in the intersection part in here. Okay, so that just gives you like a quick rundown of Venn diagrams. Hopefully you remember that sort of thing. Now some definitions about Venn diagrams. So A union B is the same as A including or united with B, and this shaded part over here represents everything that we would find if we found A union B. So in this case, A union B would be all of the numbers between 1 to 9, basically. So, but just not 10. A and B is the intersection of A and B. So upside down U. In this case, it's just the shaded area that I've got over there. So for here, it would be 2, 5, 6, and 7. All of the other numbers would be not included. This little dash means complement. So this one is A complement. That means that everything that is not in A, and I've tried to define that by the shaded bit there. In this case, everything not in A would include 8, 9, and 10, because all of the other numbers actually exist in A. Things can get a little bit more complicated. It might say, find what A and B is, and then find the complement of A and B. So this one here would be everything that's not in the intersection of A and B. So in this case, everything that's not the numbers 2, 5, 6, and 7. So it would be 1, 3, 4, 8, 9, and 10. Okay, just hopefully I'm just reminding you of a bunch of things that you need to remember. So if I have this, probability of A, that means that the chances of A are happening. So the number of A outcomes over the total number of outcomes. Now back for our example before, we had 1, 2, 3, 4, 5, 6, 7. So it's basically 7 out of 10. That's the probability of A occurring. We know that the probability of anything occurring must be between 0 and 1. The probability of A being equal to 0 means that it's impossible, it can never happen, and the probability of A equaling 1 means that it's certain. So you can't get a negative probability of anything happening. Okay, and you can't get a probability of greater than 1 as well. A couple of things along with that, the probability of A plus the probability of A not happening, so A complement, is that must equal to 1, because these are all the things that happen in A, and these are all things that don't happen in A. Those two must complement each other to equal 1. And so what we can often do is we can often rearrange that equation to make, to find out the things that we want to do. And often, finding out, whether something can or can't happen is easier if you find out the other thing. I'll have a look at that a little bit later. Okay, so we'll keep going with this. Let me show you a rule that is always true. This is the law of total probability. So the probability of A or B happening is the same as the probability of A plus the probability of B minus the intersection of A and B. And if I quickly draw that over here, if I get all of A, which is all of this section here, and if I get all of, I'll shade that in, and if I get all of B, which is all this bit here, and I shade that in, as you can see, I'm going to shade the middle part twice. So therefore, if I want to get what A and B is, all of that, I have to subtract one of the middle terms because I've actually got it twice in there. Hopefully that has helped a little bit. But there are some special cases with this. sometimes you have this thing called when something is mutually exclusive, which means that they have nothing in common. They can't both happen at the same time. For example, people, the transportation coming to school, people will either catch a bus or they'll catch their car. Let's exclude the people who catch both. Let's just assume that you can either do one or the other. You can't do both of them. So in that case, the probability of A and B happening is actually equal to 0. So the law of total probability actually just condenses down to this here. Okay. The other thing that can happen is that something can be independent. And so that means that one event doesn't influence the other one. So for argument's sake, rolling 2 dice, if you got a 6 on the first dice, what's the probability of getting a 6 on the second dice? Well, it makes no difference because the first dice doesn't affect the second one. So the probability of A and B happening is actually equal to probability of A times the probability of B. That's not always true. That's only true if it's independent. In fact, that's the test for independence. Okay. Sometimes that is not a good assumption to make in our maths. So a couple other things you need to remember is you need to remember that like these maps, how do you say that? Is that Carnot maps or Carnot maths or Carnot maps? Who knows? Whatever they are, you need to remember that this bit here is B and A happening together, B and A not happening together, and I guess these also condense into probability tables as well. So these are, I guess, consistent with numbers of people doing things, and this one is probability of people doing things. And for this one, each column and row need to add up to 1. So B plus not B must equal to A, and A and not A must equal to 1 as well. Okay. The last thing I want to go through with you for this video is conditional probability, and we've sort of looked at this in another space, but we need to have a look at it here. And this is one of those rules that kind of always works as well. So conditional probability means that given that one event has already happened, what is the probability that the other event will happen? So for example here, what's the probability that A will happen given that B has already happened? And the equation for this that equals the probability of A and B happening at the same time divided by the probability that B happens. Basically, this is changing our sample size to only include the B items, and we're trying to work out what when A and B happen together, given that B has only happened. Okay. Now, a couple of things that you need to remember, or I guess you can rearrange that equation to to make all sorts of things if you need to find out different things. The assumption that this takes is that probability of B is not equal to 0, so probability of B is possible. And I guess something that can happen or can come up is that sometimes the terms can be independent of each other, which means they actually don't, they're not. I guess they're independent, but they it doesn't actually work the way that it usually works. And if they're independent, that means the probability of A and B happening together is actually equal to the probability of A multiplied by the probability of B. So what you end up happening is probability of A and B is actually probability of A times the probability of B all over the probability of B, which means those two cancel out, and all you get is the probability of A happening. That's if they're independent, they actually don't affect each other at all. But that only happens sometimes. It doesn't happen most of the time. Okay. So hopefully that's just a little bit of a recap of some of the probability things that we've done last year. In the next video, I might just go through a couple more things, and then we'll get into some exercises for chapter 8. So thanks for watching.